and the title of my mini project is EEG Data Feature Extraction Interface. The scenario of this mini project is that a machine learning company is developing an interface for user to perform power spectral density feature extraction for EEG dataset, in particularly the SID4 dataset. This mini project will be focusing on the interface itself and the feature extraction capability. The SID4 dataset follows a naming convention where the last character of the file name reflects the emotional state. For example, for 1-1s, it reflects a sadness data. The SID4 datasets contains 62 channels, and the use case of this project is such that it is only interested in the left and the right data, but not the middle data. The module that is being used is the OS module and the subprocess module. The main module used for the GUI design itself is the TK Inter module. Here is the wireframe and the code for the GUI. This is the EEG data feature extraction interface class. This is the constructor method that initializes the GUI, and this is the create widgets functions which populates the GUI. So there's the output directory frame, browse button, file table, which is global, and there's the button frame that contains all the buttons, the progress frame that contains the progress bar, the log frame that contains the log label and the log box, the clear button frame that contains the clear log button, and the exit button frame that contains the exit button. So the browse function is linked to the browse button. The log function logs the text in the log box. The add CSV function populates the file into the file list and the file table. So add directory pops up the directory adder. Add file pops up the file adder. Remove file removes one or more files from the file table or the file list. Reset file remove all the files from the file list. Show output directory function, which launch the output directory in Explorer, and clear log function, which clears the log. The programming method for feature extraction calls for various data types, various data control structures, and the NumPy Pandas Skippy module. So this is the flowchart of the feature extraction. So starting off, we'll be loading the SID4 dataset with the pandas and the NumPy library. And then we'll be segmenting the data with sliding window technique. So just for context, the sliding window technique is mainly to reduce any transient features that may be in the signal. So we'll be getting like 128 data points with 50% overlap. So the next frame will be from the 64 to 128 plus 64. So that is for the sliding window technique. Next up is the filtering of the data into different frequency subbands. The subbands that we are interested in is the alpha band, beta band, delta band, and theta band. I'll be doing this using a Chebyshev type 2 bandpass filter. So this is a function that is available in the skippy.signal library. The next one is after filtering, I'll be converting the data into the frequency domain, and I'll be doing this using the fast Fourier transform, which is also a function of the Skippy library. After the FFT, I will be getting the maximum PSD feature for each frame, and then writing the maximum PSD feature for each frame for each frequency subband into a CSV. So there will be 4 CSV, one for each frequency subband, and each row of data is the maximum PSD. After that, I will be accumulating the data from all the 4 CSV and then averaging for the left and the right hemisphere for each of the band. So the final CSV that is expected is a CSV that contains 9 columns So alpha left referring to alpha band left hemisphere, alpha right refers to alpha band right hemisphere, and then the beta right, delta right, theta right. So that is the 8 columns, and an additional column will be the emotion class. So this will be extracted based on the file name. If it's a ending with a S, then it is a sadness data. F is a fear data, and so on and so forth. So the eventual PSD file, a summary PSD file, is also a CSV format, and it can be further used for machine model training. So that's all for the feature extraction flowchart. This is the feature extraction function. This is the sliding window technique parameters, filter parameters, definition of the 4 bands, the filters creation and design with 40 dB attenuation at different frequencies, the hemisphere mapping using dictionary, and here is some GUI update and processing of the each EEG file. So for each EEG datasets, it's gonna read and load the datasets, create a output directory according to the file of the dataset, create a PSD results dictionary, and for each channel, it's gonna segment them into the data frames, and for each frame, it's gonna apply the filter, perform the FFT to get the frequency domain, and get the PSD by performing the square function and then getting the max of it. This maximum PSD will be written to the band PSD CSV, and then the average of the left hemisphere of each band PSD will be calculated and written to the final PSD summary. And a column of the emotion class will be added based on the file name. This is the function that is linked to the start button. It will look for if there is a output directory or any file selected. If yes, it will run the PSD extraction in a separate thread to the whole GUI. This is their interface. First, browse to the output directory. Then, add the dataset that you want one at a time or multiple at a time by selecting the whole directory. So it will be logged as below. You can remove one file or multiple file, or you can just reset the interface to be empty. So I would like to add 3 files now and start the feature extraction. So the progress bar will start loading. And once it is done, there will be a pop-up that says all files processed and saved successfully. So the Explore button can be used to launch the output directory. And here is the output file, the 4 band PSD file, and the PSD summary file. So at this point, if I want to restart the process, I can use the reset button to reset the interface. And if I don't want, I can also clear the log and exit the software. So it will exit with no error. This is the original dataset. There are 62 rows for 62 channels and multiple columns for many samples. This file will be processed to produce the band PSD CSV. So this CSV should contain 62 columns for 62 channels and multiple rows for the multiple data frames. And eventually the average of the left and the right hemisphere will be obtained and written to the PSD summary CSV. So there should be 9 columns: alpha left, alpha right, beta left, beta right, delta left, delta right, theta left, theta right, and the class. The class is based on the file name of the CSV being processed.